Hello, today I'll be going over modular arithmetic and go over basics and advanced of it, as well as some divisibility rules which will be helpful in contests. So first, what is modular arithmetic? So modular arithmetic is arithmetic, but basically with the remainders. So what I mean by this is, let's say I have some number 7, and I'm asked to take mod 4 of it. This is the notation which we write it in, 7 mod 4. The answer of this would be 3. And what this basically asks us is, what is the remainder when 7 is divided by 4? So the answer to this question is, when 7 is divided by 4, the remainder is 3, right? So let's go over a few more examples. Let's say I'm asked to take the number 14 mod 4. Then we are asked, what is the remainder when 14 is divided by 4? In this case, if we divide 14 by 4, we will get 3 remainder 2, meaning that 14 mod 4 is equal to 2, or it's basically just the remainder. So always think remainder when you're thinking about modular arithmetic. Another type of example is, let's say we're asked, what is 14 mod 7? In this case, we're asked, what is the remainder when 14 is divided by 7? When we divide 14 by 7, we get 2 remainder 0. So there is really no remainder. So in this case, our answer would be 0. So this is how you can calculate these simple modulars, or using modular arithmetic. Now, one last type of example is, say we are asked to compute -3 mod 4. So whenever you have something such as this negative in the modular thing, what it is asking you to do is, what is the remainder when -3 is divided by 4? In this case, when -3 is divided by 4, -3 is less than 4. So we will end up with a remainder of -3 itself. However, this -3 can be converted into a positive value. And this is simply done by taking conjugates, basically. So this -3 mod 4 is equal to, or congruent to, we write it in a notation known as congruency, 1 mod 4. And you can actually test this out. And the way we can do this is by taking this number which we're modding it by, and then having this -3, subtracting it from that number, and then that gives us our 1 mod 4. So if this is your first time learning about modular arithmetic, that might have been a little bit confusing to you. So I'm just going to go over a few more examples with variables. And these variables are actually different types of problems that you can see in contests. So let's say I have some number x, and I write it is congruent to 1 mod 3. This means that the remainder when x is divided by 3 is 1. So for example, if x is equal to 1, then we know that the remainder when 1 is divided by 3 is 1. If x is equal to 2, the remainder when 2 is divided by 3 is 2. So therefore, this value of 2 does not actually work as a solution. If we set x equal to 3, the value when 3 divided by 3 is 0. So it does not actually work as a solution. When we write x equal to 4, the remainder when 4 is divided by 3 is 1. So it does work. And if you continue writing this, we will see that certain values do work and certain values do not work. Now, one common thing which you will notice about all of these numbers is that x is basically congruent to 3k plus 1. For any positive integer k, this equation holds true. Because if we write the number 3k plus 1 mod 3, we know that 3 mod 3 is 0. So this 3k cancels out, and we're left with a 1 mod 3, which is exactly what we have at the top. X is congruent to 1 mod 3. And you can actually see this by trying out these examples. We have x equal to 1 work, where k is 0, and we have just a positive 1. We have x is equal to 4 works, where k is 1. X is equal to 7 works, where k is 2. So this is a very simple way of how we can take variables and manipulate them with modular arithmetic.